this week's offering of Morning Joe, and as we always do, let's start off with some headline news. I bet you guys can guess what I'm going to say is headline news today. Any takers? Oh, you guys need to fire up your browsers.
Supreme Court ruling.
Yep, Supreme Court upholds nationwide health care law. In other words, in King v. Burwell that I've been talking about, Burwell won. In other words, the Supreme Court has agreed that all the subsidies that people that sign up for Obamacare get, even though they used a national exchange as opposed to a state exchange, the subsidies will hold. It stabilizes the healthcare industry quite a bit. All the healthcare stocks are surging, but it does set a dangerous precedent in that that's not the way the law was written. It's the way they intended it to be, perhaps, but not the way that is written. So the dangerous precedent is that if any law comes before the Supreme Court or any other court that says, well, we didn't really want it to work this way, they can say there's precedent. Even though it wasn't written this way, our intention was X, and they now can cite precedent. So that's a bit of a slippery slope there. But so that's a huge, huge decision coming out of the Supreme Court today. So check your news feeds and you can read all about it. All right, today should be a fun one today. I really like not just the topic today of analytics, big data, but the originator of this presentation, Robin Bloor, is a fantastic speaker, exceptionally well known, internationally known, and a really, really good person that puts complex terms into easy to understand sound bites. So if you guys can see my screen, Analytics and Big Data Analytics by Robin Bloor. Okay. The advance here. So what are we going to look at? There's his Bloor group. So we're going to look at a few things. Data science. What is the nature of analytics? Machine learning and other things. Machine learning will become exceptionally important as we go through time here in this next year or two. Machines learn so much faster than we do. What's it all mean to the business? And what does the future hold? Okay. I really like this slide. Does anybody know the TV show that is based on, or this slide's based on? You guys are into binge watching. I think it was it's either Netflix
Breaking Bad.
Breaking Bad, absolutely. So I thought this was a great takeoff of the Breaking Bad slide, only because, hey, I'm a fan of the periodic table, let's face it. All right, so data science, what is it? It doesn't exist. According to Robin Bloor, it's a misnomer. There is no data science. All it really is an advancement on what we've already done. So much like physicians come up with fancy names to mean things, the business of BI and analytics comes up with fancy names to rename things. If you're a doctor and all of a sudden you see a diagnosis, episodes of syncope, that's just their way of saying, oh, they fainted. So in the BI world, there's no data science, misnomer. All science is empirical, involves data analysis, and that's what I've been saying for a while for those of you that I've had these discussions with. A data scientist is nothing more than a data analyst that's got some stat skills. That's really, really what it is. So you can see kind of the picture off to the right of that building. Another trivia question for you while we're looking at this. The artist that draws those types of buildings, anybody know who the name of that artist that draws those types of things? That's a really esoteric question. That artist is known as Escher. So you often see the workings that look like that, the kind of really cryptic looking buildings. So all science is empirical and involves data analysis, and science implements a method, as do statisticians. So data scientists are nothing more than data analysts that have a pretty good scientific method behind them and have some skills. What is a data scientist? Now, I had to put this on for Jason on the right here. Guys, if you see the little name tag down there, I couldn't help it. I edited Robin's presentation on this. So what is a data scientist? Data scientist is a project manager because they have to, because that's all good data scientists or all good analysts in some ways manage the project. They're qualified statistician, and by that I mean they just don't do rudimentary stuff. They know their way around numbers and how to build them. They're domain business experts. They know how to interpret those numbers and how to interpret the data that they see in meaningful business ways. So this is a little bit of a departure from a normal data analyst that just kind of looks at the data. Now you're requiring of these people to not only know their way around numbers and know their way around data, but to understand the business principles behind it. That's why these guys get so much money. That's why these guys are sought after, because not only are they I wouldn't say IT, but technology experts, but also business experts, the important mix of both. They're experienced data architects. They know how to put data together. They know what should be put together and what shouldn't be put together and how that works. And they're good software engineers, which meaning most data scientists not only know data analysis and statistics, but they know how to code. They usually write things like Python or R for statistics. So you kind of get the ultimate of three skills: business knowledge expertise, data expertise, and statistics. So, I mean, it's really a triple threat. The vision behind this slide is that it's really a team. Claims that business analysts can be data scientists are dubious. Now, and the reason is just because you're a good business analyst, you can't be a data scientist because you probably don't have the stat. You don't have the background. You don't have the knowledge of information theory and how to put it together. And that's why if you see any of our clients that we go to and talk, well, we have good business analysts and they're going to be our data scientists. If anybody says that to you, you can kind of cast a jaundiced eye at that because it really doesn't work that way. You need to have years and years and years of training in stat to understand how it works, not just the generic stuff. And no matter how well you use your tools or the tools that make it easy for you to actually run the numbers, it's the interpretation that makes a big difference. You can get Excel to run stats for you if you wanted to, but it's what you do with it and it's what it tells you. That's what you need the training for. You need to be able to understand the difference between correlation and causality. Software understands nothing, as he says. It just implements the algorithms. If you don't know what it means when you do that, it's pretty useless, and worse than useless if you're untrained, like some people are, and you run these things, you can make really, really wrong assumptions. And you guys have often talked about Tableau as a good thing, but if you don't understand the data and how to put it together, you can really run into some problems. All right, so what are we looking at here? Who understands data? Question for you guys: what are these four graphs showing you? What is that graph? What are they trying to show?
Upward trend.
Upward trend, okay. An upward trend meaning what? It's the best fit around the line, right? What they're trying to do is show, okay, here, given a smattering of dots, what's the best fit line that I can run through those dots, right? And in some cases, the fit is pretty good. Some cases, it's lousy. But the interesting thing is, it's the same line no matter which kind of graph you're looking at. So in the upper left, you see, a pretty typical kind of a scattershot thing that says, okay, you know what, here's all my dots, and the best fit line on those dots looks like that, pretty much 45-degree angle slope, fine. One to the right, oh, now you still got a best fit line through that, but look at the data, what it's telling you. It's like, oh yeah, it's peaking and then it's dropping. A best fit line over time is just going to drop. You can see it by looking at the dots, right? Bottom left, pretty good calculation here, but it's slightly dropping, so it's not a bad, but you got an outlier here, so that means something. And then the bottom right, this is a meaningless line. So you've got a bunch of stacked dots sitting at value 8 here, one at 18, and now you're trying to draw a best fit line from that. Does anybody think that line shows reality? No. What this is telling you is that any statistical process can draw a best fit line, can run the numbers, but you have to understand what you're looking at. So it's the information behind just the running of the stats to that. That's really what that's telling you. Nevertheless, of course, Einstein here, the only way to know more about a business is from its data. By any other means, that's the only real way to know you can't do. You can do sentiment analysis and sometimes quantify that, but when the numbers hit the page or the numbers tell the whole story when the rubber meets the road, and that's the best understanding of a business. So let's look at the nature of analytics. The field is business intelligence, and I haven't seen it really described this way before, but it kind of makes sense. You can think of it as 4 buckets: hindsight, oversight, insight, and foresight. So what is hindsight? That's regular reporting, operational BI. That's what happened, right? What's the monthly numbers? What did my sales do? What did my shipment do? Whatever. Operational BI. Oversight, dashboards, OLAP, BPM, business process management. Guys, those of you that take the class, what's OLAP stand for? Okay, business refresher for BI. Online analytical processing. That means making sense out of the numbers, as opposed to OLTP, transaction processing, which is just the detailed transactions. Insight, which you get from data mining and stat analysis. And foresight, predictive analysis, predictive analytics, right? So from hindsight to foresight, you're going from the least complex to the most complex. You're going from what happened to what might happen. It's a nice way to encapsulate the entire field of BI in 4 simple steps. And the driving force is insight, right? So hindsight combined with insight leads to foresight, really. And you have to do a lot of the grunt work around putting those operational processes in place, because that gives you your baseline, and then you can predict trends off of that. Now, process is not an activity. Data analytics, multidisciplinary, end-to-end process. You just can't, grab data and run something at the end and say here's the answer. You really have to understand the entire path that the data, the information traverses from coming into your company to going out. And it's gotten a lot better recently and a lot easier because the tools have gotten better, right? You get more data, there's more data out there, which does lend itself to some challenges because then you got to pick the right data. But the technology is getting so much better for you to look at trends, things like Tableau that shows you visualizations or easy dashboards or whatever. It's much easier now to look at how a data moves through a company than it used to be. You used to have to cherry pick and write SQL and grab things out of databases and then try and make sense. So the ability to understand these things has gotten a lot better. But you still need that skill set to say, what does it mean? So while the tools have gotten faster to run those stat processes, the actual underlying math behind statistics hasn't changed in 100 years. A frequency distribution, a best fit line curve, ANOVA, online variance, ARIMA, online moving average, those stat processes, they haven't changed their math because the math doesn't change. You just get tools that make them run faster for you. Here's the detail. So for those of you that like flowcharts, you can think of, in the way you read this, it's kind of going right to left. You have the data prep and extract, whether it's sample data or subject data, it goes into model, and you continually iterate on the model and analyze, does it fit, does it fit, does it fit, and then you get the results. And then that's why he calls it an iterative loop on both of these things. You're always working to make the model better. And in fact, in some analytics, there's a coefficient of correlation known as an R factor. The higher the R number, the more likely it is that your model is predictive. So all models are predictive, it's just how good. So if you start to get R values, up in the 80s, almost never seen, by the way, but if you start getting into that value, you really get a predictive ability in these models. So it's a measurement of how well those models predict. So it's an important thing to keep in mind that you can run the stats, you get results, how close is it? And then we talk about the critical workload issue, and this is not the guy that I've hired to do my backyard in terms of overloading the dump truck. But previously, we viewed database workloads as an I/O input-output optimization problem. In other words, we kind of thought of it as how much can the machine work, and what's our ability to feed it data and what's its computational speed. But analytics workload is different. it's a variable mix of I/O and calculation. So in a lot of cases, you don't need a ton of data to do the right prediction. Just the right data. And conversely, no matter how much data you have, you won't get the right prediction no matter how much data you write through it. Databases weren't built to do this. Databases weren't built for analytics. Not even Hadoop and the other databases you want to think about that run big data. They're not designed for analytics processing. They're designed for storage and retrieval, regardless of analytics, and that's really what they're built for. So kind of gives us an inherent problem of trying to feed analytics correctly. And again, that's why you need the skills behind it to understand what data you should be putting into it. Now, the big data people that build Hadoop or the other databases would tell you, oh, that doesn't matter. We'll store everything and process everything efficiently. Yeah, that's because they're in the business of building databases. What you really need to know is what data do I need and how much of it do I need. Machine learning. This is going to be huge. Machines learn so much faster than we do. And so, here's the data latency guy. Here's the guy waiting for his results, right? Sitting at the computer waiting for his results. So where are the latencies in all this? What do we wait for? Data access. People are waiting for data access. We had a call this week, and one of the guys saying, well, I can't get the data I need, and he just can't get it. So he's continually waiting on access. Data prep. How many times have we heard that the guys that are running the analytics in companies are upset because their best analysts are stuck in data prep mode? They're always putting it together, spending 80% of their time trying to put the data together and only 20% analyzing it. You wait on model development. You wait to make sure that data models are built. That's why Tableau came into existence. Doesn't need a data model, so you can become effective, sometimes highly ineffective if you do it wrong. You wait on execution. You wait on implementation. You wait on auditing the models and updates. So there's a lot of wait time involved in analytics that has nothing to do with machine ability or statistical ability. It's getting the data to the results, through to the results that you want via all the processes that are involved. Speed is equal to value, probably. Okay. Open sources help things, and you recognize the Hadoop elephant there, as long as the R penguin. R, again, is a statistical language. It's a coded language for statistics. You can actually write, best fit line calculations or all the stat processes you want, and put them in stream to your data. And the reason it's important, in the old world, when you just had your standard databases, you would be able to take data out of those databases and feed SAS, for example, as a tool to understand statistics. But you can't do that. You have to go to the data now because it's so big. Big data is so big, so fast, so changeable. You can't move data to your processes. You've got to move your processes to where the data is, and that's what R does. Hadoop and its ecosystem, MapR and things like that, reduce latency because you can actually partition the problem out as parallel processing. And machine learning algorithms, which really is raw power, make the machine learn. None of these are engineered for performance, however, they're engineered to do a task. So here's a list of machine learning algorithms. It's not important that you know what a neural network or a Bayesian network is. There's just different means that machines learn. And all it is, a machine will just execute what you tell it, right? And these are just complex coding algorithms. If you tell a machine 2 and 2 is 5, it doesn't know that that isn't truth, and it'll just execute that way. So there's a bunch of different ways that you can have machines learn, and all this is really saying, here's different ways to slice and dice the data that the machine can get a result out of. But they can do it really fast. They're not newly invented. Obviously, all of these statistical processes, as I've said, have been out there for years and years and years, but now we have the power to execute them. And so what that really means is that you can turn a mediocre analyst into a really, really good analyst if you can iterate on that process fast enough. And the cool things about machine learning algorithms, again, if you can run them fast enough, they can check all possibilities. And that's what actually the first chess playing program did. It actually learned all of the possible calculations that a chess move can have, and there's billions actually, depending on the move. And that's why machines seem a lot smarter than we are, because they can look so much more ahead than we can. So parallelism is going to change the game. Humans think serially for the most part. Machines can think in parallel. The faster the machine, the more parallel paths it can take. And when you start chopping the problem up and working on multiple things at once, the speed is only limited by how fast and how many parallel lines you can draw. So the analytics team in any company needs to understand that the ability of the machine to execute will be at some point instantaneous. The ability of humans to make sense of it all is not. But machines, you can actually start to code intelligence into machines where they can start making sense out of the data. Hopefully people code that correctly. And that is the basis of what's known as AI, artificial intelligence. What's the business perspective on this? The role of data analysis hasn't changed. Only the speed will. Processes will evolve, and it will be disruptive for all the vendors out there. I'm sure SAS right now is wishing that the internet and big data had never occurred, only because they own the space in statistics by building SAS and all its statistical processes that you would feed it data and out would spit a result. And you just can't move SAS to where big data is right now, and I bet they would like to torpedo R if they could. So incumbent vendors are going to have a problem with this. Data analysis budgets are going to increase. We're going to focus on the business problem. No more are you going to have your data scientists, data analysts sitting in the back room crunching numbers. You're going to bring that to the forefront out in the business world, and make the people that know the business make the mechanics of statistics a lot easier for them. And manufacturing is a useful analogy to think of how you can actually automate things and put all those processes front and center in the business world. Okay, what's the future? And there's a reason that Robin picked, and a tarot card picked the Fool, because no one can predict the future really well. And he gave this talk to in Rome to an Italian audience. Non è finita fino a quando la signora grassa canta. It's not over till the fat lady sings, right? So there's disruption in both hardware, software. Business processes are going to get disrupted. All we know, analytic processes get faster because machines get faster. The latencies will reduce in some cases. In other cases, getting the data latencies will increase. Data will grow, but analytics will be the differentiator. Summary of all this: data science, the nature of analytics. Data science is a misnomer. Again, it's really just advanced understanding. The nature of analytics, it's going to change. Things get faster. Machine learning will strip our ability to understand, especially when machines start teaching machines. And what's the business perspective? Again, it moves out of the backroom IT number crunchers front and center into the business world. And the future is what it is. Questions? Okay, I really like Robin Bloor as a presenter. He makes it good. And again, grazie mille per la vostra attenzione. Thank you 1,000 times for your attention. Okay, guys, we're at 4 minutes till. I like this as a good background of how analytics is going to change. Any thoughts, questions on any of this? Does it make sense to you?
Definitely. I liked when I read it when you first sent it. I was like, oh, if you do it for somebody like me, it was interesting. I actually read it twice. So yeah, very good. Except for I'm mad that I forgot what OLAP was.
Tom, when we're talking with our customers, the slide, the field of business intelligence, can you go back to that?
Yeah, I probably can. So I think what
the number.
Yeah, it's up towards the front, right?
Yeah, or the middle, yeah.
Was this the one you wanted?
Yeah, yep. That's a really interesting slide because obviously folks are using business intelligence for different reasons, and it can help us craft the really, I think, effective messages to them. I don't know, maybe it's just an observation that I found this slide really compelling, and I would look for ways to work with you to figure out how to leverage what this slide's saying and make us more effective.
Yeah, I think you're right, because it kind of encapsulates everything that is BI from hindsight to foresight, and putting it in these kind of terms. So if you're talking to a client and they might say, oh hey, yeah, we're in operational BI now, but we really want to get to insight. So it gives you an easy to understand graphic of where they might be able to pigeonhole where they are versus where they want to be. So it's something we can work on. Yeah. Anything else? Cool, guys. I'll give you about 2 minutes back. We'll stick this on YouTube and see how that works, and then it'll be available ongoing. Thanks. Go out and have a great day.
Thanks, Tom.
Thanks, Tom.